Question 1, an equilateral triangle has side length of 10 units. What is its area? So first thing I'm going to do is just sketch myself a rough estimation of what an equilateral triangle might look like. I might be a little bit off, but you guys are good at pretending with me, so we're good. All right, now, in an equilateral triangle, we know that all the sides have the same length. So all these sides, if one side is 10, then all of them are 10. Now you might have to think back a little bit, but the formula for the area of a triangle is base times height divided by 2. And height is always perpendicular to the base. So these two have to be perpendicular. Well, I don't have any lines here that are perpendicular because remember that perpendicular means 90-degree angles. So what we have to do instead is we have to draw in a perpendicular line. So we're going to take a line from the vertex and we're going to drop it straight down to the base, and this is going to be our perpendicular line right here. So in order to figure out the height, we have to figure out this length right here. So there's two different ways to do this. One way is to use the trig functions to find the height, and the other way is to find special right triangles to find the height. So, if we were to use special right triangles, remember that this is an equilateral triangle and we get 30, 60, 90-degree triangles from a right triangle, or from an equilateral triangle. So if I know that this whole side or this whole side is 10, then we know that just this little piece right here is 5. So remember, going from the hypotenuse to the short leg, you divide by 2, and to go from the short leg to the long leg, you multiply by the square root of 3. So this length over here would be 5 times the square root of 3. So this length here is our base, and this length here is our height, and we just have to substitute these into this formula over here to figure out what our area is. So using 30, 60, 90, we get 10 times 5 square roots of 3 divided by 2. And when we multiply these two together, I can only multiply these two because these are the numbers. This one is not actually the number 3, it represents a different number. So 10 times 5 is 50 square roots of 3 divided by 2, and now I can simplify these two numbers again because they're not underneath the radical sign. So the area for this would be 25 square root 3. The other way that we can do this is by using trig functions. So I'm just going to start this over. I'm going to redraw our triangle. Oh, such a good triangle. And again, we need to know this height here. We know that this is our 90-degree angle. We know that this is 10. We know that this is 60 because it's an equilateral triangle, so all the sides have to be congruent, or now all the angles have to be congruent. So this triangle right here, we are trying to find this length x. So here's theta, remember our buddy theta, and here's our hypotenuse. So label your triangle like we've been talking about, and across from this is our opposite. So we don't need the adjacent because there's nothing down here. There's no labels, there's no numbers. So we only need the opposite and the hypotenuse, which is sine. So sine of theta is equal to the opposite over the hypotenuse. So the sine of, not theta, but we know what theta is 60, is equal to the opposite, which is the length that we're trying to find, over the hypotenuse, which is 10. So since the number is on the bottom, we're going to multiply both sides by 10. And so x will be equal to whatever we get when we multiply 10 times the sine of 60. So let's just pull up our calculator. 10 times the sine of 60 is 8.7. We're going to round that to the nearest tens place. So 8.7 And now that we know that, now we can use our formula again for the base, which again is 10, and the height, which is 8.7. So you notice that this is not going to have any radicals in it. So the area is equal to base times height divided by 2. Our base is still 10. Our height is 8.7. And so 10 times 8.7 would be 87. And this would be units squared. And again, units squared.